All right, I mentioned yesterday that we'd get a little bit more into rounding at a later date, and that later date has come today. In 2000, the population of Dallas was 1,188,580. Round that number to the nearest 100,000. Well, first of all, let's locate the 100,000 place. It's this one right here. That's 100,000. So if we're going to round to the nearest 100,000, what we need to do is look at the next place, and that's that 8, the one immediately to the right of it. Now, any number that's greater than 5 means that we're going to round up to a 2. And 8 is greater than 5. So we'll rewrite this number as 1,200,000 people. And the reason is 180,000 is closer to 200,000 than it is to 100,000. So we'll go up and we'll just call this about 1,200,000 people. All right, so what about with a decimal? Let's round 3.14159 to 4 decimal places. By the way, that's a 5 decimal approximation of pi. 4 decimal places. Okay. Well, let's identify the 4th place. It's that 5. And then again, we look immediately to the right of it. We see that 9. And that 9 being greater than 5 means we're going to round that 5 up to a 6. So anytime the digit to the right is 5 or more, I'm sorry, I think I said greater than 5. I meant 5 or more. That means to round the digit up. So we did. We rounded it up to a 6. The price of regular unleaded gasoline was $2.19 Round that price to the nearest cent. Yeah, I see that we need an I right there. We'll fix that. Okay. So we're going to round this to the nearest cent. All right, here we go. So we're looking at that 9, and immediately to the right of it is 9/10. Okay, well, 9/10 is more than half of a cent. So we're going to round that 9 up to a, well, really we're going to round the 19 up to a 20. You're not just going to round the 9 up to a 0. We are, but we're actually taking it from 9 to 10. So we'll call this $2.20. Okay, so if you have to round a 9 up to a 0, that affects the digit to the left of it as well. Some people get really confused on that. Look what happens up here when I make those corrections mid-recording. Estimate the height of the ceiling in our classroom in meters and feet. Well, you're not sitting in the classroom right now, but you can take a look at this tomorrow, or you can just kind of look at your own room. I'm looking at the door that's immediately across from me. I know I'm 6 foot tall, and I walk through a door with pretty good ease. So a doorway is about 7 foot tall usually, and then the space above the wall looks like it's 2 to 3 feet. So that on top of the 7 feet would be 9 to 10 feet. I don't think it's 10 feet. Let me call it 9 feet. If it was 10 foot, I probably would have a heck of a time jumping and reaching it. So I'll call it 9 feet tall. And there's about 3 feet in every meter. That's not exact, but so if it's 9 feet tall, we'll call it about 3 meters. And obviously, growing up in America, I'm used to measuring things in feet more than I am meters. So I kind of start with the English system of measurement and then go to the metric from there. Estimate the sum of 3,879 and 5,276. Okay, well, 3,879 is about 4,000, and 5,276 is about 5,000. 4,000 plus 5,000 is about 9,000. And some might say, well, that's so easy, Mr. Kaczynski. Why do we even need to bother? Well, now we've got a reasonable answer. We know that this number plus this number is about 9,000. So if I took your calculator away from you and you added these up and you got 90,000 instead of 9,000, then you should know just by estimation that your calculation is wrong and you need to go back and find out where your mistake was made. Let's do it again. Let's estimate the product of 12 and 3/8 and 9.75 by rounding each number to the nearest whole number before multiplying. 12 and 3/8 to the nearest whole number is 12, and 9.75 to the nearest whole number is 10. So 12 and 3/8 times 9.75 is about 12 times 10, which is about 120. Okay, and again, now that we know it's about 120, if you actually try and multiply these two numbers, either by changing 12 and 3/8 to a decimal and multiplying them together, or changing 9.75 to a fraction and then multiplying the numbers, you should know that your answer should come to around 120. If it doesn't, then you know you did something wrong with your fractions or decimals. Here's an example of what I'm talking about, of why estimating is a good idea. Gus works 39 hours for $9.85 per hour. He calculates that his weekly paycheck should be $38,415. Good job, Gus. What is a reasonable estimate of what Gus earns, and how do you suppose Gus arrived at his absurd calculation? That's an editorial. I put absurd in there. Well, obviously Gus doesn't make $38,000 a year making $9.85 per hour. There's nothing wrong with that wage, but you're not going to make $40,000 a year, or I'm sorry, a week, maybe a year. That's way more reasonable. Well, let's look at this. A reasonable estimate would be to say, okay, 39 is about 40, and 9.85 is about $10. He's making about $400 this week, not 40,000. How do we suppose Gus arrived at his calculation? He probably left the decimal place out of 9.85. If we left that, if we multiply by 1,000 here, we'd have an extra 2 zeros. That would be 40,000. So that's probably what he did, is he left the decimal point out. So he's not going to make $38,415. He's going to make 38,415 cents. That's kind of a big deal, Gus. A rectangular room is 11 3/4 feet long and 10.5 feet wide. Grace calculated the area to be about 124 square feet. And let's explain why we think her calculation is reasonable or not. Well, let's look at this. I'm going to say that her estimate is reasonable. And I'm going to defend that answer. It's reasonable because a 12-foot room by an 11-foot room is about 132 square feet. So on the high side, if we rounded both of those dimensions up to the next whole foot, her room would be 132 square feet. So, I'll go a little further here and say the actual dimensions will be a little bit less than 132 square feet. Even on the low side, if you rounded both of those dimensions down to 11 and 10, that would be 110 square feet. We know it's somewhere between 110 square feet and 132 square feet. 124 is between those two numbers. So it seems like a reasonable estimate to me. It is 6:05 p.m. and Eduardo is driving to Dallas. If he is 157 miles away and driving at an average speed of 62 miles per hour, is it reasonable that he can reach Dallas by 9 p.m.? Explain your answer. Well, I'm looking at it as 6:05 to 9 p.m. is about 3 hours. And if I multiply that by his speed, which is about 60 miles per hour, then he's going to travel about 180 miles in 3 hours. Okay, so is it reasonable that he could reach Dallas by 9 p.m.? Well, if he can go 180 miles approximately, then he can certainly do 157 miles. So it is reasonable. He will reach Dallas by 9 p.m. All right, that's all I got for you today. See you tomorrow.